Welcome to the episode of AI Ranch, where we see how the AI affects the businesses all around the world. My name is Evalds Urtans, and today I have a special guest, Jānis Jasko, who is a very innovative entrepreneur in the field of precision robotics in agriculture. So welcome.
Thank you, Evalds. Happy to be here.
So let's start with your personal story. You're not actually, as I understand, initially roboticist, right? You have some very diverse background, and also you're even a PhD, right?
Yeah, so my background is not in robotics. I'm biologist by education. Spent some time in plant protection, so researching how different kind of chemicals can help farmers to increase yields and decrease weed pressure or disease and pest pressure. I studied PhD. I didn't finish my thesis, so I'm somewhere in between of finalizing it. But now the focus is on a business, so it somewhere in the future to finalize my PhD. But I like research. I like innovating things, and this I think the main reason why I'm so deep into this innovative business of developing new technologies for weed control. And personally, for me, I have worked in different kind of research before, both in academia and in private segment. And as my latest part of the career was connected with plant protection, at some point we saw that, okay, there is a need for farmers to have something more sustainable and that we can replace the chemical inputs in the food production system. And we saw this opportunity of using AI and lasers to help farmers. And now, for more than 3 years, we are building our company around this technology.
Excellent. What motivated you from going from research, right, from academia into something very, something very unpredictable as a business, right? Especially in hardware and in AI and all of these components which are emerging, right, which are not something that is straightforward.
So building a startup around the hardware there is a lot of red flags, a lot of reasons why not to do this.
Just the first flag, hardware, right?
But I think it's somewhere deep in every one of us. So someone likes to build something quick and big, and somebody likes just to play around with the hardware. And this is something also for me. I like making physical things. I like to see how my work is afterwards used by other users. And as the farming is close for me, and I spend my childhood in countryside, and my parents also had a farm, so it's quite natural for me to continue on this. But as you mentioned, this is not an easy journey, hardware itself, and especially in the specific segment of ours. And to be able to continuously work in this, you really need to have some kind of passion. So there is no logical reasons why to step into this segment, just that you want to do it, and this is somewhere inside of you.
Yeah, so it's you have also this personal aspect from your childhood. So by the way, great name, WeedBot. That's perfect. You're the only WeedBot in the world, right?
At the moment, yes. When we thought about the company name, so there were different options, and this stood out. So both from the straightforward point of view, so because we are dealing with weeds, at the same time there is a lot of other use of the name weed, and this also attracts some.
Yeah, sure. So please explain how WeedBot works and what it does and how it makes money.
So in WeedBot company, we are building machinery for organic and conventional growers that use AI to detect and recognize plants, separate weed from the crop, and then we use high-power laser that targets the weeds and eliminate them in the field. In such a way, farmers can keep clean fields with only the crop. And so if the weeds are not developing, so if unwanted plants are not there, so they are not using nutrients, and in such a way the crop gets enough nutrients, gets enough sunlight, and we get a healthy food, a good yield for the farmer, and better for the environment. With our machine, the farmer can replace use of herbicides, so can replace use of chemical plant protection products in such a way, making both better for the planet and better for us as a consumer, because a lot of these residues of the chemical plant protection products are left in the food, and with eliminating them from the production process, we also make life better for us, the health better for us.
No, that sounds amazing. Like lasers and robots and so things like that. So okay. So how successful are in the numbers? How many units you have pre-sold? What stage you are? That would be interesting as well.
Yeah, for us as a hardware startup, it's always hard with getting at the point of sales very quickly. For us, we are now finalizing our commercial unit, and we are doing the field test for last couple of months, mainly in south of Europe. We have already pre-orders of multiple units, so we are not trying to build a very long list of pre-orders just because our machinery is like really big. One unit will cost about 350 up to $500,000. So this is quite an investment also from the growers. And that's why we keep close relationship with our initial customers. We have some of them already for 2 years supporting us. We have growers that have invested in our company just to see our company developing quicker, and so we can develop product quicker and bring it to the market quicker. So we feel a really big support from our end users, from our customers. And also during these 3 years, we see that awareness of the farmers, of the society in general, moving more openly towards new technologies, because although lasers sounds very nice and cool in the field, and we have a lot of supporters in the beginning, the farming society is still quite a conservative one, and they need time to take in all the new technologies, to familiarize with them, and then be more open to them. And now during these more than 3 years, we see that with each new video that we release, how we are working, how we use AI to recognize, how the lasers act, we see more and more interest and more acceptance from the grower. And now lately we have been in an agriculture fair, a big one in Germany, in Hanover, Agritechnica, and we see a lot of growers coming and saying, "Hey, I have seen your videos. I really like your technology. I'm ready to buy. Just say when the product is out there in the market, and I will come and buy it."
And comparing to other hardware that farmers use, like price-wise, yours is 350K. What are the typical prices of other hardware they use and how it comes together?
This is also the good part, that farmers, at least big growers, are used to have a quite expensive hardware already. So, for example, in the same segment that we operate, the weed management, eliminating unwanted plants. So the farmers already are buying machines 100, 150, 200, 250,000 euros. These are smart hoeing machines using cameras to guide the hoes, guide mechanical tools. So they are already more or less okay with this kind of high cost. And this is just quite simple from the farmer's perspective. So they are not just buying something expensive because it looks cool. They are calculating how much of effort of other resources they can save. And with our machine, they can save a lot of manual labor. I know that a lot of general population think that already everything is mechanized in agriculture, and there are already drones flying around, but it's not really the case, not in Europe, not in the US, and not in Australia, not in developed countries. There is still a lot of manual work. And just to put an example, so now organic growers, those who are not using chemicals, one of the big problems for them is the weeding. And so to remove weeds, the typical methods here in Europe, big countries, France, Spain, Germany, and also United States, it's manual work still. So behind the tractor, you have a platform, 10, 15 people are laying side by side. With face down,
robots,
and just like a human robot, just removing the weeds. And as you can imagine, it's not the most favorable.
Are they lying on the belly?
Yeah. On the belly, you have special support for the head, so you can not to make problems with your neck. So it's really hard work. And if outside there is plus 30, plus 35 degrees, or in California even plus 40, so it's crazy. It's very, very hard work, and there is not a lot of persons willing to do this. And this is where we step in. We're saying, hey, we can replace all of these hardworking people with much more sophisticated technology, and this makes a lot of sense because the manual work is not only hard for the workers, it's also quite expensive.
That 10 workers. And in the developed countries, the minimal salaries are quite high. So that.
Exactly. So the salary rates is growing every year, and in all countries there is quite big reliance on imported seasonal workers from neighboring countries, but it's also getting more and more complicated. And we saw quite a big shift in thinking during the COVID time when the borders were closed, and some of the farmers experience high problems in field just because they were not able to bring in any seasonal workers. So this has also helped them to understand that manual work, this is for some time okay, but this is not something in future in 5-10 years. So they need to replace it with.
Yeah. So your technology is like fundamental for scaling the organic agriculture. It seems like. By the way, are you the first mover in the market, or you see other companies? What is the competition? How far did they get? What is the situation on that front?
Yeah, so in precision weeding, which is our specific segment, or precision agriculture in general, this is a huge movement there regarding the laser weeding, which is a very specific niche, just because this allows to be very precise and target only the unwanted plants and not targeting the crop. In this segment of laser weeding, there is a couple of companies. So there is one larger company from the United States as a biggest player in the market. We see ourselves as a second, very close to the commercializing, and with our machine in the field, we really see this huge advancement. There are other companies also working in this field, but more, maybe with connection to university and research type. In general, the lasers in the field is not something really new. There are some research done in this field already from 70s. So the researchers are thinking about quite long time already. But now is the moment when the technology is ready, and crucial part for us is the AI part.
Yeah.
So, and this is ready and applicable, and also the computing power is there. So you can put quite nicely, quite a strong computing power inside in the machine, and this brings everything together. That now is the time when this kind of technology can really be built and make it economically feasible and deployed.
So you say that this has been already idea for a longer time period. And you had some experience in research, and I think you also had some experience in intellectual property, right? So do you have any patents, or is it possible to patent anything there, or what is the situation of intellectual property?
Yes. So lucky for me, I have spent some time in in intellectual property right protection. And for us, yes, we have applied for multiple patents. We have already granted some in Latvia, which is the simplest way, but we have also one international patent application process. So in this area, you cannot protect general things because this is already described and everybody knows that, but some specific aspects. And we also feel that the approach that we are using, how we process information and how we apply our laser is a quite unique one, which allows us to be very fast in the field, use a very limited amount of computing power, and this is the one specific niche that we are putting our protection on. I have seen other companies also trying to protect something, but you cannot protect general ideas anymore, but some specific technologies that you have developed, this is the way how we can still make our technology protected.
Do you already see some collision between the other companies that work on this field with their patents and what you do, or right now?
Not at the moment. Yeah. At the moment, I see the interest for the smaller companies to work together, because yes, to be honest, in the hardware, it's not so simple. The investment amount is quite large, and at the same time, there's not too many specialists in the area that work in this field. So you still need to gain quite a lot of knowledge to be able to combine all these optoelectronics together with AI, computing, embedded software to make it work. And what we see that those who work in this area are recognizing that this is a quite huge task that needs to be done. And maybe it's even better to combine forces together to bring it to the end users.
Okay, and So just before going into AI, which is the core of our interest, so it just mentioned that you were working with markets in Southern Europe, right? What markets are the best for this technology, and what is the size of what is the opportunity there?
Yeah, regarding the markets and the size of our company that we are looking for. So usually it's medium to large sized growers. In the vegetable segment, it's more not so big like in grain, like those who produce wheat or corn. They are in thousands of hectares. In vegetables that we are working mainly now, it's more like starting from 50 hectares and up, 50 to 100 hectares. It's already companies that we are working. We have also, of course, also larger companies, several hundreds of hectares of vegetables, which is even for the Europe quite large growers. And from the size perspective of the countries, then yes, in Europe the main vegetable growing countries are in south, so Spain, France, but also quite a lot of growers also in Central Europe, in Germany, Netherlands, also in UK. So also Poland, Hungary, Austria. So in principle, we are more looking on a grower size and the interest from the grower, less on the country where they are located on. We also see quite an interest from North America, so Canada and US. But for us, the plan is start in Europe as a home market and then move to overseas.
And then let's say there's in France some kind of 50 hectares. What kind of vegetable, cabbage, or what do you prefer?
There are mainly two these directions. Either they are more operating on a monoculture way. So, for example, if they are mainly focused on carrots, then they grow carrots and maybe potatoes to make a rotation. And these are more for the small, medium-sized farmers. There are smaller farmers who grow a lot, like starting from cucumber, cabbage, potatoes, onions, and so on. And then there are a huge grower who have 1-2 specific products. Like we have growers focusing only on carrots and having like 400, 800 hectares of carrots only. And then other crops also like leafy greens, onions, beetroot.
Okay. So let's say 50 hectares of carrot, France. So there's the labor costs right now. They do this funny method with lying on the belly and pulling out the weeds, organic farming. Okay. So and then you give then they buy your device for 350K. So what is the expected return in what time estimate and money wise?
Yeah, it's really, as always, depends on the economics of each grower, how well they are operating with their other parts of the business. But in principle, it pays back in a couple of years, and then they are already making the profit of the machine. So for the agriculture machinery, this totally makes sense, as they are used to this kind of payback time for the machine. As growers usually are not there for 1, 2, 3 years. So if they have a company in the growing business, so this is for 10, 15, 20 or more years. So they are quite dedicated for this. We have quite a lot of our customers who are in generations. So this is already growing business, farming business in generations. So that's why I like farming. They are looking in very long perspective. So talking with them in 10, 15 years, it's like normal discussion. Yes.
Yeah, cool. So they understand nature, how things advance through time. So that's something. The digital age is very different. So very short attention spans. And what about the partnerships with other manufacturers? We have seen, I think, the robot tractors, right, from John Deere, right, do you talk with them, and do they have interest? And what do farmers say about these robot devices already on the market?
Yeah, this is the good thing in agriculture. And agriculture machinery. Everybody more or less knows each other. And also for the cooperation point of view, so there are 2 ways that we are working on. One is the cooperation for production of machines. So of course, we as a startup We don't have a huge manufacturing hangars behind us. So we are cooperating regarding the manufacturing. And the second aspect, as you mentioned, is regarding this our implement on agriculture robots. Because to be honest, these autonomous tractors or agriculture robots, they are only useful for the grower if they have some kind of smart implements also. Without implements, this autonomous tractor is just a toy, so it doesn't do anything. And from the grower's perspective, it's the same. So they are they want to buy not only the tractor, they want autonomous tractor, they want to buy solution. And for them, solution is something that is done in the field. It's either plowing, seeding, tillage, or anything else. And from this perspective, so we are still moving ahead, not so quickly. So we have nice agriculture robots with some capacities, and this is already good. But in the same time, the big boom will come when the implements will get more smart. And this is also what we are looking for with the partnering together with the robot manufacturers. So with our machinery, with our laser weeding machine, their robot gets much more added value to the grower than without it. And that's why we have also the quite large interest from these robotic companies to make fully autonomous this laser weeding technology. For us, we see there's still some development steps needed because still in Europe, there is quite a lot of safety regulations in place, and that's why we need to make our machine very safe in any conditions, whatever can happen in the field. And in the field can happen a lot of things. So you can have wild animals, you can have birds flying around, or some stick just coming out of the ground. So this is like ordinary situation, and you need your machine and also the tractor to be able to recognize this, either as a threat or not threat, and react properly. So that's why I see that the autonomous tractors and robots are coming in. Farmers already are starting to use them, but we will see a big boom in a bit longer future. Hard to say now whether it's 5-10 years or longer or shorter period, but it will come as soon as the society will be more ready for it, and when the technology will be even a bit advanced more than now, and also maybe regulation will be less strict, because now, to be honest, Europe is very strict in regulation and autonomy in agriculture. We see less regulation in, for example, Australia. So it will really depends which country will make the strategic decision that we want to be the forerunner in this segment of autonomy in agriculture. And farmers from this country will benefit a lot.
Yeah, I agree that there's in Europe there's a lot of trigger-happy regulators that want to regulate everything, single thing possible. So hopefully at some point we'll not come to the situation when WeedBot needs to go to Australia or some other country to succeed.
Yeah, I really hope that the legislators in Europe see that not only technological wise we can be in front, but also from legislation point of view we need to do as much as possible for the startups for new technologies to develop, and not to put some secret stones in a way for them.
Yeah. Right now, the AI Act is also one thing that not only for the hardware startups, but also for software and the AI will be a challenge. And let's hope that it will not be as bad as it sounds. So then regarding the AI component, which is, as you said, historically been the stumbling block for developing such great technology in the past. So what has been your experience so far? How important this component is for your device and how it actually works?
Yeah, for us, the AI part is one of the major blocks. Without AI, it's not working. And it took quite a lot of time for us to put everything together. In our case, we are doing all the recognition and computing on the machine itself. So we are not sending any information to the cloud and back, just from the practical point of view. In the countryside, especially in Southern Europe or also in Western Europe, the coverage of broadband networks in the rural areas is not so great. So sometimes in the field you don't have any bar of the mobile network. Yes, so this is quite an issue. That's why everything for us is built in, and for us to be putting for each laser unit a separate component, separate processing unit, is quite expensive. And that's why we also need two things. One is the AI network, which can run on a quite decent GPU or CPU usage. And also the price for this unit should be reasonable to make it economically work. So for us, we are training our network to recognize different kind of things. We started with just recognizing the crop, and we thought, okay, this will be enough. And after some initial trials, it works. But then you always get on some kind of edge cases, and you say, okay, this first approach worked in a certain percentage, and there is something still left. And that's why now we have a multi-layer system, which use different kind of AI and also non-AI based recognition layers. And this in total works very well. But yes, as we are operating in very high resolution, so we have high resolution camera in our system. We use very high frame rate. That's why we get a lot of information, and we need quite a powerful computing unit also on there. And yeah, we are taking image from the top of the ridge, putting it through our AI to recognize weeds in the crops, and then separating them, and then applying laser just to the green parts of the weeds in such a way as they're eliminating fully them or stopping their growth. So this means that there is a lot of images running through, and we need to process them while in go.
So the high resolution camera, so instant segmentation probably, or some kind of segmentation model. So this is kind of NVIDIA Jetson GPU or some other platform. What do you use?
Yeah, we have tested different products of NVIDIA, also Jetson family, larger computing GPUs, ordinary GPUs, high-power GPUs, and now we have some kind of balance found. We see in the future that we can use smaller computing power with the next versions as also the AI part develops. At the moment, we found some system that works more or less okay. In the same time, the conditions in the field are not so stable as in the office. So that's why there is always a trade-off of the price, how secure system or how good system is in the outside environment, and what's the price of it. And we need to find some kind of a balance. We cannot put a very
And what kind of crops, what kind of weeds you detect, and what is the expected accuracy actually on the field on average?
Yeah, at the moment we are focusing on one crop. We are working with carrots only, mainly because we are a small team. In a WeedBot, we are 3 to 4 full-time persons, depending on the season. But yeah, for that we choose the focus to be on a one crop. And this is also interesting part, because when we started 3 years ago, there was one way how AI models were trained, and now with the release of Annotate Anything with ChatGPT, there is a situation is changed, can't say dramatically, but substantially comparing to what it was 3 years ago. And we also see that our focus on one crop was quite good, because now we can do the same amount of work with much less resources. If you would spend the same amount of money 3 years ago, now we would, yeah, I would say now we would really regret it, because now we can do the same with much less resources necessary. So yeah, from practical point of view, at this moment we work on a carrots as our first crop. We see that we can implement the next crop in just a couple of months, and the biggest part of the training for the next crop is just acquiring images. It's not the training itself, it's just getting the right image, because for the plants, this is also an interesting part. When the plant grows, in different growth stage, it looks totally differently. And if the person, for the person, it's easier maybe to interpolate. So see, okay, this is a small plant, now it's bigger plant. So for the AI model, it still needs to be shown images in all growth stages. So this also takes a more effort for us to take images in the whole growth stages of the plant and different soil types, different conditions.
Yeah, very interesting task. Imagine that you have different species, different cultures, different growth stages. Then you need to decide: is this one model? Is this separate models? How it comes together? Like lots of interesting things there.
Yeah, there's quite a lot of tricky parts, and this way I also mentioned that we started with one model. We thought everything should be great because the AI is so clever, so it should learn quickly. And then you understand, okay, there is some limitations for each of them, and as closer you want to get to the 100%, which is this ultimate goal, of course, you separate 100% of the crop and 100% of the weeds. And then you realize that this is the ultimate goal, but from practical point of view, it's most probably not even any time reachable. So when you need to finalize somewhere close to this.
It's also not that bad for viewers also to understand. In deep learning, the machine learning, you can fine tune the parameters and the hyperparameters so that you eliminate false positives. So in the sense that even though it would not target every single weed at every single frame, it will not target the carrots, right? So it's you should not be worried that it will destroy crop. So it will just improve, but how much it will improve, right?
And also regarding the AI part, it is always the play of the parameters. So you always can squeeze them and to get 100%, but this is only on these conditions. And then something change in the field, and you are really down on recovery rate or precision, for example. And this is the constant struggle for us to find the balance when it's still generative enough, so they can also work well on some kind of situation which the model has not seen. At the same time, we don't want to too much of fine tune it to the exact conditions.
Yeah. So the reality is on the field, there's probably dirt, there's dust, there's lightning conditions, right? So the question is how are you dealing with all of these uncertain conditions, and also like if I would run it on real conditions over these 50 hectares, right? How approximately what is the percentage of the weeds it will eliminate with one pass or multiple pass from your experience?
Yeah, this coupling with uncertainty is something that we're still working on. So in base conditions, what we want to do is to have as much as possible images close to the real life. That's why we have an image database from all over the Europe, from continental part, from United Kingdom, Latvia, Spain, France, and also different kind of conditions: big, small, large weeds, small weeds. Regarding the precision rate, we are still working on this, so we can reach up to. So the aim for us is 85% plus of the weeds killed, or at least treated. So we are still in our way to be there. So we know how to reach it, but as I mentioned, the field conditions are sometimes even trickier than we think. So that's why we can reach 75-80%, so which is already good. But yeah, we want to push it more.
And how did you practically count it? Somebody goes and counts the weeds?
Yes, this is the most interesting or fun part in our business, that you really need to be on your knees on the field and count. Otherwise, it's not working quite precisely. But this is also the way how the farmers and research organizations are doing this. So both with the chemicals or other methods. So yeah, you're in the field, you count which is treated, not treated, how the carrots look like. And this also gives you the reality check, because it's always nice running models and get some statistic back and maps and these kind of parameters. And everything looks fine. And then you're back in the field, and then you start counting 1, 2, 3, 4. Okay. What is this? We haven't seen something like that in the office mode. I think this is also for our company, which gives us this advantage that we are in the field from day one. So not only trying to build some kind of just AI behind it, but everything starting from software till hardware was tested in each stage in the field. So putting something together, more or less work, then we put it in the field and test, and then we get the quick feedback back what works in reality and what works only in our imagination.
I assume the data set is a huge part of this. So the approximately what is kind of your size of data set, what kind of species you have, what kind of weeds you have. Do you see differences in data set across the regions? Do you have like how important is that part of the business?
Well, yeah, for that set, I can't say real exact numbers of it. I need to ask my colleague Andres, who is making the AI part. But for us, the main aim is to gather as much as possible to the real life where we're operating. And that's why each farmer that we have, we try to gather images. We have built special device for that so that we can gather image in the same way as our machine does, because this also makes a difference. If we gather images in different way, it's not working nicely afterwards. Regarding the weed types, this is also interesting one because we can have one grower with specific weed only for them, and the approach that we are taking is if there is something that totally differs from what we have seen, or even it's not necessary to differ, it's just enough if in our existing data set it's like a 0.0 percentage in images, this kind of plant, and now it's like in every image. Already the recognition works not so perfect, and then we are adding more these kind of images with this particular weed in most cases, and then it's of course quickly improves the recognition rate for this particular weed. We have also interest from the grower just to apply laser for a specific weed. This is mainly for conventional growers who say, okay, we have weed resistance problem, so the chemicals are not good enough for one particular weed, and so they say, okay, for us, if you can target only this species, this would be great. Mm-hmm. And this is also interesting task for us, because now it's not only the recognizing the crop, but recognizing specific weed and targeting only this one as a priority. This is quite fun.
Okay, and you had also some, as you said, fun. You had some funny experiences with your device. You know, like I don't know, like some what happens if the like rats or some other animals or you know, like somebody left something on the field. Hopefully, the laser would not, you know, destroy something like that. Or what happens in these cases? Do you had some experiences like that?
We get this question quite a lot. What happens with something else which is there with insects? But in practical life, in real life, usually nothing happens to them because we are applying laser only to the weeds. And as long as the rat or anything else doesn't look like a weed, it won't be targeted by the laser. We have quite a lot of videos with ladybugs coming out after the laser and looking happy after this. And this is also very important to compare our methods to the other methods that the farmer already use. And one of them comparisons I like to make is organic farmers in Europe and in US using a flame weeding. Flame weeding means that behind the tractor you have a propane tank and they have nozzles 5-10 meters behind the tractor, and they're literally burning everything behind the tractor. So this is a organic methods allowed in Europe. Every large farmer in Europe are using this. And after this flame, nothing alive stays on the field. And comparing to this flame weeding, our method is like a scalpel compared to the cannon or something like that. So after our methods, even if there is some collateral damage, is so minor that nobody in field perspective can notice it. And this is also goes with all the beneficial organisms in the field.
So when the device is operating, you are not afraid to put your hand in there?
Or you're from a safety perspective, so we do all the safety instructions, so do not put hand beneath it. But in practical point of view, as long as your hand doesn't look like a weed, it shouldn't be targeted by the laser.
And how did you try? How much pain it is if it actually hits you?
Yeah. During the development phase, you can get.
Did it hit you sometime?
I have also get scars from it, so it really can cut through the skin. So it's powerful enough. So that's why I do not try to play with it as a toy. It's really powerful lasers, so that's why each of operators are trained to work with it, and it's really can do some harm if it's not used properly.
And the how much it costs for you for the others thinking about the hardware and AI business, right? Money wise, like to build this functional device, like from the perspective of hardware, lasers, and then from the perspective of AI component and data, like what is the cost threshold for this kind of business?
Yeah, this is always tricky one with the hardware, and in general, building something that works, it's not so problematic. So if the interest or hobbyist wants to try it, buying in eBay or somewhere else a small laser and connecting with a small camera and computer, this can be done as a small interest project, €100 or something. And the tricky part starts when you want to apply it on the field condition and to make it really work. And then goes the costs in hundred thousands of euros, just because the hardware is quite expensive. And also the skills for someone to make it all happen. It rarely are one person able to do everything, starting from optics, electronics, embedded software, AI programming, image gathering, evaluating in the field, and then it's stuck together. And this is also what makes it so complicated to operate in real life in farm conditions, because it's not enough to make something working in stationary mode. Take an image, send it to the processor, process it, and then target somewhere with a laser. You need to do it while tractor is going, so you have images flying in, and you need all the algorithms in place to process them and to actively steer the laser beam while moving with a tractor. And this is when it gets complicated, when it gets costly, and when this investment money just
so let's say the
quickly.
hardware part would cost about, like, for a proper device for the first round, but like 200K. Then the software component, how much you estimate time-wise, money-wise, it costs to build something functional? Of course, not production ready, but at least functional.
It really depends on who is making it. We have seen companies struggling with the software for 3-4 years, with several times larger budgets than us. We have done it with investment money in a couple of years, improving. So we build first functioning this, as I mentioned, there is a stop and go method, which is simple, and then you have a continuously driving method. We were able to build a continuously driving machine in less than 2 years, and this is something that we see that a lot of other initiatives are struggling with. So
is it about the same money, like 200K to build any kind of AI system, or your experience, it's more or less?
I see that we have built it with a couple of €100,000, and I have seen other companies with a couple of millions budget struggling to do this. So it really depends, I think, regarding the persons doing this. This is not.
So you think there are also these engineers that are involved in these very innovative projects? It's very important how skilled they are in terms of limited budget, right? And in your case, I assume you have some skilled people behind you, right?
Yeah, this way I can say big thanks to our team, because putting together not only the software, but this all optoelectronics to work, this is the tricky part. I often get the questions, which is the most complicated, the hardware or the software part? And if you look on them separately, so it's not complicated one and other itself. The most tricky one is making everything to work together as one system and operating in a millisecond and microsecond mode. And this is when it gets tricky. Then this when you need to really apply knowledge, and this is not enough for software guy, for example, say, okay, I build this AI model, just I finished my work, I take it, and this is very good. In our case, it doesn't work. So in our case, we have the whole flow, which needs to operate in millisecond mode. And each of us, in such a way, need to be fully understanding the whole process. And if one of the aspects is not working, we are not able to show the effect at the end. And this, I think, what really differs how our company and team is different from the others. So each of us have been in the field. Each of us has counted the weeds there, and then they looked that this is the result of your work, and there is some bug in the system. So all of us need to go back and then find where is something not working right. And
well, it's not only money; it's the expertise, it's the skills, it's the all that things.
Exactly.
So that's that, and then to finalize, we would like to get your perspective on the effect of this AI technology and robotics in agriculture in the future, because from what I looked up in 1900s, like let's say more than 100 years ago, it was estimated about 40% of population was working on farms. Now today it's 2%, and it's still feeding the whole world. I think it's actually kind of a great example of people being worried about ChatGPT and all of the AI is taking the jobs, because all of those people that time also, if they know the statistics, they will think, what we will do, right? All of the jobs are gone, but everybody lives and everybody have the job. So how much more we can go? Like, is it 0.2% of the population feeding the whole world? What is the effect of AI? What is the effect of all of these technologies?
Yeah, I would say we can definitely go less than 2% just because of technologies. And regarding the AI, we already see that a lot of applications for them, starting from what we are doing on recognizing the plants and applying the weed removing systems, not only with lasers, but also with other mechanical tools already used, more simple models, but AI deployed in the field and working there. We see AI used for analyzing data from different kind of sensors, because farmers are using more and more sensors for soil, moisture, weather conditions, pressure of potential pests and disease. And this all together gives a lot of information. And to process that, the AI really is a tool that can process a lot of information in quick time. It's still there. It's still coming, because sometimes in agriculture, not all data are very well structured and in such a way that they can be fed into the AI models. But I think it's definitely will be there. The other great part is the spatial analysis of the fields. Also, nowadays farmers have images from the drones, from the satellites, Sentinel satellites, for example. And some of the farmers already use it, but the bigger added value will come when there will be not only the colors of the field saying, okay, in this field there is more moisture, in this less, and the farmers need to think something. But when the advice from the AI will come, you need to do this and that in this kind of part of the field. Now this still mainly goes for the farmer, but when there is no need for the farmer to analyze something, then there will be also no need for the farmer to go somewhere. There will be enough for the satellite image to be processed by AI, and some irrigation system opened or closed, or robotic weed management tool sent to the particular part of the field just to do this or that. And this is what I think will be the biggest added value for the growers. And
this seems exciting future. It almost sounds like the farmers will sit in the chair and control everything from device. But probably will not be like that. Probably still you have this connection with what you're growing in the field. So really excited to talk to you today. There's so much more to discuss here, but we have limited time. So really wish you the best luck of raising your round now. If any investors watching, this seems a good opportunity. The pre-sales, the technology, the market seems promising. Okay, so thank you very much for joining me today.
Thank you, Evalds, for inviting me, and yep, good luck for other startups in hardware, because hardware is hard, and so we need to stick together.
Thank you for joining this episode of AI Ranch. As a gratitude, please subscribe, like, and share, and see you in the next episode.